All right, so now we're going to be looking at finding an area. But when you're trying to find an area, it's kind of weird because normally area has things like a base or a height or, more than one measure. This just has one measure. But it does look pretty regular, and that means regular means that this is all the same. Okay, so we need to find some information because here's what I'm eventually going to go for. If I were to kind of start from the center, and then I could build triangles like pizza slices all the way out to each of these corners. Now, I'm guessing where my center was, and I'm definitely off by a little bit, but that's okay. It's more just approximating. So there we go. There's our pizza slices. But let's say I wanted like this one here. Well, that one there is kind of interesting because, well, not that one there, but any of these would be interesting because what I can do then is let's give ourselves some blank space here. There we go. If I were to have a triangle like this, I could find the area of a triangle. I know that. That's just area equals, 1/2 one dimension times the other, the base times the height kind of thing. Base times the height. And they already gave me one of those. They gave me this base. They said, oh yeah, this base is 7. No problem there. But now I see something else because what I can do is if I were to kind of think about, well, what about the height of this triangle? What would that be? The height, I could figure that out if I knew this angle right here, and then I could do like a SOHCAHTOA relationship. So if I knew that angle, then I could figure out this distance there, then I'd be set. Well, let's see if I could figure out that angle. I know that there's a number of sides going around here. Let's see how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so there's 11 sides. And that means that there's 11 angles. For the interior angles, when you're trying to find the total interior angles, well, I know it's kind of here, one way that you can think of it. Well, if I have all these triangles and I want to add them up, I can't really count these ones. So there's like 11 angles going around the outside. So what could I do then? Well, I guess I could say there's 11, or I should say 11 triangles. So that's like 11 times 180. But then I got to take out this circle because I'm not counting that. I'm just counting these angles going around the edge is what I'm looking for. So I'm a minus 360 there. So let's see what that calculation would be. That's so 11 times 180, and then we're going to subtract 360 from that. So that's 1620. All right, I could deal with that. That's not too bad. Let's see if we can get back into here and take it back to this. Excellent. So that equals 1620. So the total of all these angles is 1620. But there's 11 of them. So each, that's the total angles. So that means that each one is going to be 1620 divided by, well, how much is that? That'd be divided by 11 because there's 11 of them. All right. But then wait. That would be a full angle like this, the whole thing, and we only want half of it. We just want this piece inside here. So then we're going to take half of that as well. So we're going to take 1620 divided by 11 divided by 2. Let's see what happens. So we've got 1620. Oh, it was already there. 1620 divided by 11. And then divide that by 2. And that's 73.6363. So let's just say, we'll just round it up. We'll just say 74. No big deal there. So this equals 74 degrees. All right, let's again get some workspace there. Excellent. All right, so now we got each angle is 74 degrees. So that's 74 degrees going into this triangle or into this corner angle. How does that help me? All right, because now this 7 would split up into two pieces, 3.5, 3.5. So I have really a right triangle that's 3.5. This is 74, and I'm trying to find what is this. Well, that gives me like the opposite side and the adjacent side and an angle. So if I'm thinking like my SOHCAHTOA pattern, SOHCAHTOA, which one of these uses the opposite and the adjacent? Well, that would be the TOA combination. So tangent 74, whoops, no, what's 6? Not 6. 74 equals the opposite, which is our height, we don't know what that is, over 3.5. Now to solve that, you multiply 3.5 to both sides. 3.5 times tangent 74 equals our question mark. Let's see where that takes us. So that's going to be 3.5 times tangent of 74. There we go. Close it. Equals 12.2. So the height then is 12.2. So what's this height right here? It's 12.2. Wait. That's the height we needed. That was this height right here, 12.2. And this base was 7. So the area of one triangle was 1/2 7 times 12.2. Well, let's calculate that now. We're getting so close here. So we got 12.2, well, we got it right there, times 7, and then take half of that. Divide that by 2. That gives us 42.72, right? Well, let's see what that did for us. So this area of this triangle is 42.7. Excellent. Done. Oh, wait a second. That's only one slice of pizza, and there are 11 triangles. So now we got to go multiply that by 11. That's not too bad. So this times 11. And that gives me 469.92, or really close to 470. So what's the total area? 470. About. And 470 inches squared, because it's area. Crazy. Interesting stuff there. There's a lot of stages to this. First, we kind of cut it up into triangles, cut into triangles. Then we looked at what's the this height. Oh no, then we looked at what's the angles. Angles. We found total each, and then we took half of that to find this piece right here, because this 74 degrees was half, not a full angle, but just half of it. And then the third thing we did is we figured out what's that height of the triangle, the height of the triangle. And by the way, this has got an official vocabulary name. It's called the apophthegm. And then we did the areas. That's awesome. We love triangles and simple areas. All right, so excellent. Go back and watch it again. Check it out. We'll have some more examples with maybe some slight variations later.